Welcome back, learners. In this video, we'll learn how to add and subtract binary numbers. This particular topic can be very tricky. We are used to adding and subtracting numbers in base 10, right? Now, one thing we should remember is that the digits that make up a number cannot contain the base. What do I mean? It is impossible to have 3, 4, 2 base 4. This is not possible. So it is also impossible to have 1, 1, 0, 2, 1 base 2. This is not possible. These two right here makes it impossible. However, we can have 1, 1, 0, 2, 1 base 3, right? Because the base is 3 and each of the digits is less than the base, right? 1 is less than 3, 0 is less than 3, 2 is less than 3. So that means it is also possible to have 2, 4, 1 base 6, right? Because 2, 4, and 1 are less than 6. But it is not possible to have 2, 4, 1 base 3. That's not possible because this 4 right here is greater than the base. So let's get into the first question. Now, 1 plus 1 in base 10 is 2, right? So we are not going to write 2 because we are adding in base 2. And we know that whenever we are working in base 2, we cannot have the digit 2, right? So when you add the number normally, I mean naturally, in base 10, the answer is 2. 1 plus 1 is 2. So you ask yourself, that value that you get, the result, now divided by the base, which is 2. So 2 divided by 2 is 1 remainder 0, right? That is, we don't have any remainder. So it is the remainder that you're going to write. So in this case, 1 plus 1, we say it is 2 normally, I mean, naturally in base 10. But because we cannot write 2, so that result divided by the base that we are working in, which is base 2, will give us 1 remainder 0. So we're going to write the 0 and bring that 1 up here. So we say we carry 1. So now this one that we just carried plus the one that we have originally here, we have 1 plus 1 again, which is still 2. 2 plus 0 is still 2, right? But because we cannot write 2, we say 2 divided by 2 again. And that will still give us 1 remainder 0. So we write the 0 and we keep the 1 here. So now the one that I just kept and this one right here, that is 1 plus 1, 2. 2 plus 1 again is 3, right? So now we say 3 divided by 2. That will give us 1 remainder 1. So we'll write this remainder first. Now we'll bring up the 1 here. So since we are not adding this 1 to anything, we'll just bring it down. So that means 111 base 2 plus 101 base 2 is equivalent to 1100 base 2. Let's have another question. 0 plus 1 is 1, right? And of course, we can write 1 since we are working in base 2. So 0 plus 1 is 1. We are free to write 1. Now, 1 plus 1 is 2, right? So we say 2 divided by 2, which is 1 remainder 0. We write the remainder, which is 0. We bring up the 1 here, the quotient. Now, this 1, which is the quotient, plus 1 here, that's 2. Plus another 1 here, that's 3. So we say 3 divided by 2, that will give us 1 remainder 1. So we'll write this remainder first, which is 1. Then we now write this 1, we bring it up. Since we are not adding it to anything, we just bring it down. So that means 110 base 2 plus 111 base 2 is equivalent to 1101 base 2. Now another question on addition. We have 0 plus 1, that will give us 1, right? Then the 1 plus 1 will give us 2. 2 divided by 2 is 1 remainder 0. We write 0, we keep 1, right? Now, this 1 plus this 1, that's 2. 2 plus 0 is 2. 2 plus 1 again is 3, right? So we say 3 divided by 2, we have 1 remainder 1. So we write the remainder and we bring the 1 here. So in this case, the 1, which is the quotient here, 1 plus 1, that's 2. 2 plus 1 is 3. 3 plus 1 is 4. Right? Of course, we cannot write 4. So we say 4 divided by 2. That will be 2, right? And we will not have any remainder. 2 remainder 0. So we'll write the 0, right? Then the quotient, right? Which is 2. So it's like you're adding this 2 to 1, which is 3. Of course, we cannot write 3, Abby. We cannot write 3 in base 2. So you do that again. 3 divided by 2 is 1 remainder 1. So you write the 1 first before you write the remainder first before you now write the quotient. So that means the sum of these three binary numbers is equivalent to 11010 base 2. Another way to look at the addition of binary numbers is to see 1 plus 1 as 10, 10 plus 1 as 11, and 11 plus 1 as 100. Now, in this first example, this one, the sum of 1 and 1, we said, let's see it as 10, right? So we write 0, we keep 1. So the one that we are keeping will be written here. Now, this one plus this one is also 10. 10 plus 0 is still 10. So write 0 again and keep 1. 1 plus 1 is 10. 10 plus 1 is 11, right? So you will see that we arrived at the same answer. Again, 0 plus 1 is 1. Now, 1 plus 1 is 10, right? We cannot write the two digits at the same time in the middle of a number. So we write the 1 by the right, which is 0, right? We keep 1. So writing the 0 and keeping the 1. So the 1 here plus this 1 is 10. 10 plus 1 again is 11, right? So we have 1101 base 2. So you can see that we have more than one way to look at it. Then lastly, 0 plus 1 is 1. Then 1 plus 1 is 10. We write 0, we keep 1. Now, this 1 plus this 1, that's 10, right? 10 plus 0 is still 10. Now, 10 plus 1 is 11. We write 1 and we keep 1. So this 1 plus this 1, that's 10, right? 10 plus 1 is 11, right? 11 plus 1 is 100. 100, right? So we write, instead of writing, we cannot write, of course, we cannot write the 3 digits of this 100. We are going to write just the last one, which is 0, and keep 10. So let's bring 10 here. So 10 plus 1 is 11. So you can use this method of taking 1 plus 1 as 10. It is actually not pronounced 10, it's just 10. 10 plus 1 as 1. Before we go into subtracting binary numbers, you can also use a longer method, which is converting each of those numbers to base 10. So in this example, let's use example number 2. When we convert 110 to base 2 to base 10, we'll get 6. And when we convert 111 base 2 to base 10, we'll get 7. So 6 plus 7 is 13, right? Now convert the 13 back to base 2. 13 divided by 2 will give us 6 remainder 1. 6 divided by 2 will give us 3 remainder nothing. 3 divided by 2 will give us 1 remainder 1. And 1 divided by 2 will give us 0 remainder 1. So reading from bottom to top, we'll have 110 base 1. And you can see clearly that that's what we got here as the solution to the addition of 110 base 2 to 111 base 2. So you can decide to use the longer method. So even if you want to solve this question number 3 using that method, converting 1110 base 2 will give us 14. 101 base 2 will give us 5. 111 base 2 will give us 7, right? So when you add these three numbers together, you'll get 26. And when you convert 26 to base 2, of course, definitely you will get 11010 base 2.